Okay, so plan today then is we want to just move forward with bonding. We want to start to look at covalent bonding. So if we go back over the previous lessons, we've done, what have we done? We've done bonding. Yeah, but what sort of bonding did we do? What have we done? Ionic we did previous lesson. We've done metal, so we've done metallic bonding. So started off with the easy one. We did metallic bonding, then we did ionic bonding, we did ionic bonding, we spoke about these structures, lattices or salts, and today we're going to actually move into covalent bonding. Okay? Covalent bonding talks about these things. These things are molecules. So methane, water, sulfur trioxide, ethanol. This is what we're washing our hands with right now, okay? Because it kills bacteria. And so these are all covalent compounds, okay? The key to covalent compounds is it's non-metal bonded to non-metal. Nothing changes. The stuff that we talked about previously about trying to get a filled outer shell is the same. So with the ionic bond, one element lost electrons, the other element gained. And we've got ions. That was the ionic bond. So they lost and gained electrons to get a filled outer shell. Everyone remember that? Everyone cool with that? Alright, now, the key for the key for covalent bonding is sharing is caring. Okay? And so, I need somebody to come out and help me. Cody, you okay to be videoed?
Okay.
You come out quickly, come on. Okay. So, we'll assume that, hold that, that's supposed to be an electron. This is an electron, that's an electron. Okay? Everyone got the idea? If he had one electron in his outer shell, and if I had one electron in my outer shell, what element are we?
Hydrogen.
Hydrogen, excellent. Okay. So, is me hydrogen? Am I actually stable?
No.
I am. I've only got one electron. So, in order to get stable, I need to get an electron from somewhere else. Now, I can't do this, okay? Because it's a non-metal. I'm a non-metal. I can't actually donate electrons, okay? So this is what happens. You ready? Put it in that left hand. Where we're sharing. Ready? Give me that. Give you my electron. Okay, give me your electron back again. Same time. That's it. And then give it again. Yes. So we're going backwards and forwards. Oh, the electrons are in the middle of us. Okay? So because the electrons are in the middle of both the hydrogen atoms, I'm thinking, great, I've got two electrons, I'm happy. Okay? Mind you, the electrons are doing this. They're going pretty fast. Okay? And Cody looks and he says, what do you see?
I've got nothing, sir.
Well, if we could hold them in three-dimensional space and not touch them, but you've now got two electrons. So are you happy?
Yeah.
I'm happy because I can share them. Oh, look,
Wow.
we're sharing two electrons. Okay, sit down, thanks. Weird demo. Has everyone got the idea about the sharing idea? Okay, so we'll come and look at that example again in a real molecule in a minute. Okay, so we're talking about overlapping and sharing electrons. That's the whole key focus for covalent. Valency and covalency mean the same thing. So once we start talking about molecules, you have to remember basically how many bonds, what's the valency for element O, what's the valency for chlorine, what's the valency for hydrogen, what's the valency for nitrogen. So you've got to start to think, how many bonds can they form? And it's pretty straightforward. I think it is anyway. So, oxygen. Configuration of oxygen is 2,6. Okay? So the only way oxygen can get a filled outer shell, we're not worried about that one actually, that one there we can wipe off, but it needs to get 8 in our shell. So in order for oxygen to do that, if I draw oxygen's outer shell, 1, 2, 3, 4, 5, 6, there are 6 electrons in the oxygen, it has to share 2 from somewhere else. Typically that will come from hydrogen, it could come from another oxygen, What that means is that when we draw it, it looks like this. It could be a double share. The dash means a shared pair of electrons. Or it might look like this. It could be like that. Who knows? But every time we do oxygen, okay, in a valency scenario, in a molecule, oxygen has to have 2 bonds every single time. Yeah. Okay. Chlorine, the configuration is 287. These don't worry, they don't count for anything, they're just in electrons. So if I am chlorine, and if I have got 1, 2, 3, 4, 5, 6, 7 electrons in the outer shell, how many do I need to get a filled outer shell? 1. Okay? So here it is. I'm going to give you 1. Okay? Now that 1 electron, it doesn't come from another element, it's shared from another element. We share it. Okay? That's all we're doing. So basically it means we're overlapping another electron shell from another element that only wants to share 1 electron. And then multiple. There's not that many that can do that. Same thing for hydrogen. So we just used got here for hydrogen. Okay, and I was a hydrogen atom, and we were sharing our electron. Okay, I thought I had 2. He thought he had 2, and so we were both happy, weren't we? Yeah, we were for a little while. Okay, until he left and took his electron with him. Okay, and then I wasn't happy anymore. No, I actually kept the electron. I still got it. Here it is here. Huh. So he is now, all right, electron less. All right. What would his charge be now, by the way? No. I took his electron away from him. What would his charge be? +1. Excellent. All right. So you've got to keep thinking. All right. Now, what we're going to do is we'll actually do that. We're going to have a look at a molecular formula, what we call electron dot formula, and then structural formula. We'll come back to this again next lesson, but I didn't want to give you too much in one hit. All right, so the molecular formula. So let's assume that we're saying I am talking about the molecule of hydrogen. The formula is H2. Okay? Now, I want to do an electron dot structure. That's just the outer shell electrons. So there's a few ways you can do it. The book does it like this. That's the hydrogen nucleus. This is the hydrogen nucleus there. Okay, we're not going to locate all the protons. We're only going to draw the electrons, okay, around hydrogen. And this one here, if you haven't worked it out, that's another hydrogen as well. Okay? And so let's assume that the cross is the electron from here, and say the dot is the electron from this hydrogen atom. Okay? And so basically if I do this, if I hide that hydrogen, and I look at the number of electrons in the outer shell for hydrogen, it is 2. And for the first shell, that's stable. If I hide that hydrogen, it's 2 in the outer shell. That's stable. Okay? Everyone should be watching. Okay? That's stable. Alright. So what it does is this. So basically what we're saying is that these electrons are evenly shared, okay, between, alright, those 2 atoms. Evenly shared. How does it look? When I draw it using a structural formula, that's how we show it using a structural formula. Now, these, okay, are 3-dimensional models of molecules, and you all downloaded ChemSketch the other day. If you haven't, download ChemSketch, okay? Go forward in the lessons and download it, because you're going to need it in the next few weeks, or next week or so. So these are basically 3-dimensional models. So the structural formula is, if I had, for example, hydrogen, I'll just break some water apart. This would be the molecule for hydrogen. There it is. White is hydrogen colour in atom world, okay, as far as we're concerned. And so that is the hydrogen molecule, and that's the structural formula as simply as what we can draw it in 2 dimensions. Okay? Everyone happy with that? Yeah. Alright, let's just do a really quick introduction to covalent bonding.